So, good afternoon, everyone, and welcome to this lecture. In today's lecture, we are going to do a lot of things, and we are going to start with a very prominent concept called as the Nodal Theorem. What is this Nodal Theorem? We will get to know, but let us first see what we had done in the previous class. What we had done in the previous class, we were trying to solve some problems from circuits, whether it was the circuit for capacitance or it was the circuit for resistance. We had seen Kirchhoff's laws, and I hope you remember those Kirchhoff's law. Yes or no? And how we applied those Kirchhoff's law. Do we remember it? Yes or no?
Yes, sir.
And then we were trying to attempt some questions from your previous year papers, and you had done exceedingly well in those questions. Do you remember those questions? Okay, since I have been reminded of those questions, I will have to go and have a look back at what questions we were doing and how we were doing them. Where is those questions? Uh-uh. I've lost them. No, I have them. Okay. I'd given you some questions and you are solving them. I think this question was done. Okay. Then this one, just to check whether we remember how do we solve those questions. All these questions are taken from your previous year JEE Main as well as JEE Advanced. This one, give me the answer to this one fast so that we can move ahead and do what we are supposed to do today. So these are the type of questions that you will see in the examination hall. In the given figure, the electric current flowing through the 5 kilo ohm resistor is how much? 5 kilo ohm resistor, you want to find out the electric current. How much is that? Can anyone tell me? I'll give you 2 minutes to do this. So how are we supposed to do this one? It's a very simple question. You should not even be using your copy and pen, and you should be giving me the answer straight away. These three are in parallel. 3 ohm, 3 kilo ohm, 3 kilo ohm, they are in parallel. Yes or no? So what is the effective resistance of this?
One, sir.
1. This 1 and this 5, 6, and again this one more because of this internal resistance of the battery. So 5 plus 1 is 6. 5 plus 1 is 7. Total resistance is 7. Total battery voltage is 21. 21 divided by 7, and the answer is 3 ampere or 3 milliampere in that case, because it is in kilo ohms. Therefore, the answer is in 3 milliamperes. The answer is 3 milliampere. These are the type of question that you are going to get in your examination hall. You have to do them fast. We understand this, yes or no?
Yes, sir.
So the question that we are doing are way of a higher level. But why we are doing it? So that you understand that if a tough question comes in a JEE Advanced, you are able to do this. But these are the type of questions that are going to come, and uh, and uh, and I'm not very happy the way you are doing it. So I'll give you one more chance to redeem yourself. One more chance of redemption, and this is this chance. I hope you can give me the answer quickly and accurately. So quickness and accuracy is going to be measured here. This is the question. These are the type of questions you are going to see in the examination. The voltage drop across the 15 ohm resistance in the given figure is. See, Why I am doing this question? So that you get used to these questions. Apart from understanding the concept, these are the type of questions that are going to come. That is why we are doing it. I'll give you 2 minutes to give me the answer. Well, how are we supposed to do this? Tell me fast. How did you get 2, sir? Tell me. No one has any answer? Tell me, how did you get 2?
4 are in parallel, sir. Resistors.
Okay, so it becomes how much?
2.
2 ohms, yes.
15 and 10 will become 6, sir.
15 and 10 becomes 6, yes, sir.
8 and 8 will become 4.
8 and 8 will become 4.
12 and 12 will become 6.
6. Yes, correct. So in the upper arm you have how much?
10.
This upper arm you have 10, and then this lower arm you have 10. Okay, what next?
10, 10 and 1 are in parallel, sir. 10, 10 are in parallel, sir.
Deep breath, open your eyes and see. Yes, now tell me again.
10, 10 are in parallel, sir.
Yes, so it becomes
5.
5. Then
5 and 1 are in series, sir.
5 and 1 are in series. So it becomes how much?
6.
6. So 6 is the total resistance. So what will be the total current flowing?
2, sir.
2. So 2 amperes of current will go like this. How will it be divided in the 2 branches? Both the branches are 10 ohm each. How will it be divided in both the branches? Forgotten. Great. The only thing you have to forget is the habit of forgetting things. But you always forget that you have to forget the habit of forgetting things. Anyone?
One, sir.
It divides in inverse ratio of resistance. But here both the resistance are same. So both the currents would be same. 1 and 1. So 1 ampere current is going through this. Now, whatever is the potential drop across these 2 points, the same is the potential drop across the 15 ohm resistors. These 2 resistors are in parallel. We have found out that the effective resistance is 6 ohm. 6 ohm multiplied by the current is 1 ampere. So what is the potential drop? 6 multiplied by
6, sir.
1. 6. And you gave me the answer as 2 volt. I don't know from where you got it. It is definitely not from this universe. Probably you saw some other universe in some other dimension, and that universe enticed you so much that you gave the answer from that universe. In this universe, the answer is 6 volts. Do we understand this? Let's remain in this universe. This is a beautiful one. 4% of which you will see. It's a beautiful universe to live in. Trust me. I swear on God that this is a good universe to live in. Please stay in this universe, and we'll do some really great things in this one. Chalo. Since there is no point of doing things which are probably not going to come in the exam, even if I tell you high five fundas, there is no point, because you are doing mistakes in simple questions. So let me just concentrate on those questions first, which are going to come in your exam, rather than giving you all sorts of arms and ammunition which you are not going to use at all. This is the next question. And let's see who gives me the answer first. First, a set of n equal resistors of 10 ohm each are connected in series to a battery of 20 volt and internal resistance 10 ohms. A current I is observed to flow. Then N resistors are connected in parallel to the same battery. It is observed that the current increased 20 times. What is the value of N? These are the questions that are coming. I'm taking you from these are all questions from the previous sessions of JEE Main and Advanced. These are the questions coming. Let's concentrate on this. Forget about what I am telling you, because that is way higher than this. And if you're not able to solve this, there's no point of giving you that, isn't it? There was a very famous story about some guru and his students. The guru was Guru Drone, and the student was Arjun, and he had a son too. The name of that son was, forgot the name of his son. See, I have such a bad memory. What was the name of his son? The son of Guru Drone? Anyone knows the name of son of Guru Drone? I have to Google it. I forgot, and see my memory. Ashwathama was his son. So Guru Drona was a guru of Pandavas as well as Kauravas, and he had a favorite student, and his name was Arjun. Now, Karan was probably better than him, but Arjun was his favorite, and he taught everything to Arjun, and he also gave him the Brahmastra. Brahmastra, the movie came. Brahmastra was given to Arjuna by Guru Drona, and he knew that this gentleman will know when to use Brahmastra. He never used it in the actual war. He just kept it safe. But then there was his son, and there was this father-son sentiments. And because of this father-son sentiment, he gave the same Brahmastra to Ashwathama. Le Ashwathama, keep it. And this gentleman Ashwathama, he allowed that that Brahmas, and he did all sorts of finicky things, and that is why he is still roaming around somewhere, and some people have also seen it. So Brahmas can also only be given to person who knows how to use it. Whatever sentiments I have for you, I cannot give you the Brahmas unless until I am sure that you will be able to use it. If you're not able to solve questions like this, there's no point of doing those. Do we understand this? Yes or no? You get the moral of the story? Do we get the moral of the story? Yes or no? Huh? We cannot solve simple questions like this, which are going to come in the exam. There's no point of doing all those things, which is definitely not going to come in JEE Main at least. So, back to the question. Guru Drona and Arjuna. I am definitely not Guru Drona. And I don't. I have an Ashwathama, but I am not going to give him. I'm probably not going to push him to get into an IIT if he doesn't want to get into it. Anyways, anyone with an answer here? Or we are just chilling out with the story of Ashwathama. Oh, Ashwathama. Yes.
20.
20 is the answer. I don't know. I let's check. I did not. Since I was lost in the story of Ashwathama and Guru Drona, I could not see the answer. 20. Chalo. I think someone got an answer. That's the better part. Maybe correct or not. Let me have a look at where is the answer here. 20. 20 is the answer. And that is correct. So how are we supposed to do this? So at least we got one answer correct. Okay. So how are we supposed to do this? We have n equal resistances in series. So their equivalent resistance becomes 10n. 10 into n. And we have one more 10 the internal resistance of the battery. So the total resistance becomes 10n plus 10. The current in this case becomes 20 divided by 10 into n plus 1. And I don't know the current, so let me call it as I. I is there. Okay. Now these n resistance are connected to the same battery in parallel. and the total current becomes n times. Now, when these 10 resistances are connected in parallel, their equivalent resistance becomes 10 by n. But hey, don't forget that there is one more 10 here. The internal resistance of the battery. Now the current becomes 10 times, no, 20 times. So now it becomes 20I. And this 20I should be equal to 20 divided by 10 into 1 by n plus 1. You can divide the two equations and you can get the value of n. I think the value of n that you are going to get is 20. Everyone got this? Yes or no? Huh?
Yes, sir.
How many of you got this? I can't see you. Only one. No girls, no boys. Girls have been outclassed by boys. Shameful. Anyways, I hope we get inspired by the story of Arjuna and Guru Drone, and we try to at least hit simple targets correctly. Can you do that?
Yes, sir.
Extra, I don't believe you, sir. Your yes, sir, is very confusing, sir. It confuses me, sir. So I'll give you the next question, and if I get answers quickly enough, then only I'll proceed to do something else. Else I will wind up this one here, because there is no point of telling you something that you cannot use. This one. Who gets the Brahmastra, Agni Astra, and all those astras? 5 identical cells, each of internal resistance 1 ohm, are connected in series. Good. And then they are connected in parallel with an external resistance R. For what value of R, current in series and current in parallel will remain the same? Okay, you will not be able to do this. So I will let it go. I did not read the full question. At this point in time, you may not be able to do this. So I will withdraw this question. I will withdraw this question and I will look for one more phase saving questions. I'll look for one more phase saving question which I can give, and I can check whether check. Oh, there's no question here. Shameful act. Okay, I have a safe phase saving question, and this is the phase saving question. This is from the 2019 JEE. Oops. So I'll take this question out. We'll do it again. We'll do it at some point in time, maybe today only. But this one comes, and let's see who gives me the answer for this one. In the given circuit, the internal resistance of 18-volt cell is negligible, so it is an ideal battery. Thank God. Then the dung is given, and reading of an ideal voltmeter across R4. Now, we don't know what a voltmeter is, but basically the voltage across your R4 is 5 volt. Basically, this is what you start with. Then what is the value of R2? What type of question is this? Can you do it? That's the challenge. And how much time you have? You have 2 minutes to get me the answer. Looks like a very tough question. I'm still thinking. Guru Drone is thinking. What about the Shishas? Students. And Guru Drone is tabbed here. Let's see who gets me out of this. Sometimes the Guru also may get trapped. The students should be powerful enough to take that Guru out of that whatever. Yes. So you have 2 minutes to give me the answer. How are we supposed to do this? The only formula that we had studied in capacitance is Q is equal to CV, and energy is half CV square. The only formula that we have studied in resistance is what? V is equal to IR. That's it. One or two more, which we'll do eventually. V is equal to IR. That's it, and that is your answer. V is equal to IR. The voltage drop. Oops. See, even this thing has gone angry. It's not working. Work na. Work. Huh. The potential drop across this 4 R4 is given as 5 volt, and I also know the value of this R4 resistance 4. That means I can find out the current in this branch. How much is the current in this branch?
JEE
IR is the only formula that we know. Yes. No idea, sir. Get idea, sir. Okay, the current in this branch will be 5 divided by 500. The current in this branch will be 1 by 100 amperes. Yes or no? Yes or no? Okay. The same current will flow through this green resistor R3. The resistance of this resistor R3 is 100 ohms. So now the total resistance, because these two are in series, becomes 600 ohms. 600 ohms. The only formula that we know in resistance is V is equal to IR. From there, I can find out the value of V, the potential drop across this combination. What will be the potential drop across this combination? That is the potential drop between this point and this point. What is the potential drop? Huh? Huh? What is the potential drop? The potential drop will be 6 volt. Yes or no? Yes, sir, or no, sir?
Yes, sir.
Then what is the potential drop across this one? We don't have to apply rocket science here. Two simple things. The potential drop across this one is 6 volt. So how much is the potential drop across that one? Huh? 12 volts. Yes or no? Yes or no?
Yes.
That's it, sir. We are done, sir. Everything known, sir. Now I can apply that what? There are 15,000 different ways to do it from here. I know the potential drop across this one is 12 volt. This yellow one. Now there are 15,000 different ways of doing it. 15,000 different ways. I'll tell you one of those ways. I know the potential drop is 12 volt and the resistance is 400 volt. The only formula that we know in resistance is V is equal to IR. So from there, what can I calculate? What can I calculate? V is equal to IR is the only formula that I know. What can I calculate? I can calculate the current in R1. How much is the current going to come in R1? No idea. You can't even get idea because you don't have mobile phones. So V is 12 volt, resistance is 400 ohm. 12 by 400 will be the current in this branch. That is, I think 3 by 100. 3 by 100 is the current coming here. 3 by 100 is the current coming here. See, even this thing has gone nerd. Okay, thank God. This is 3 by 100. The current coming in this total branch is 3 by 100. Out of this 3 by 100, 1 by 100 is going in this branch. So how much is coming in this branch? How much current is coming in this branch?
0.02, sir.
Huh?
0.02.
2 by 100.
2 by 100.
The only formula that we know in current is V is IR. Now I know I. Now I know V. I can calculate R.
300, sir.
See, universe is beautiful. What we got to do in this universe is just do simple things correctly. And we will get answers. Was it so difficult that you could not do? The only formula that I've applied here is V is equal to IR. 3 times. First time, I calculated I. Second time, I calculated V. Third time, I calculated I. 3 times. Fourth time, I calculated R. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. I'll give you 2 minutes to understand. If you have any doubt, please ask. And here comes the next question. I hope you can see it. In the given circuit, an ideal voltmeter, don't worry about ideal voltmeter, we will be doing what an ideal voltmeter is. An ideal voltmeter is connected across the 10 ohm resistor and it reaches 2 volt. Similar question, similar, you can see the section, the session, it is April session, and the same question I have taken what was some other session. The same question comes from the same topic in different sessions. In the given circuit, an ideal voltmeter connected across the 10 ohm resistance reaches 2 volt. The internal resistance R of each of the cell is. There are 2 cells that are given to you. You have to find the internal resistance of each of the cell. Both are same. And again, I'll give you 2 minutes. I always believe that students are like cash vouchers. Sometimes the cash voucher may not work. That's because the code was put wrongly. Nothing was wrong with the cash voucher. 2 minutes you have. Okay, so how are we going to?
The answer is B, sir.
See, students are like cash vouchers. One of the cash vouchers did work. I don't know the answer because it's too far for me to go down and see the answer. Let us solve it, and whatever answer I get, that will be the answer. So we know that the 10 ohm resistance is to a 2 volt. So V is equal to IR is the only formula. So the current in this branch will go like this. How much is the current in this branch? Huh?
1 by 5, sir.
1 by 5, sir. 1 by 5, sir. Okay. Now, you can do this question in many different ways. Now you know that the voltage drop across this 10 ohm is 2 volt. Can you tell me what will be the voltage drop across this one? I'm trying to do it in a different way. What will be the voltage drop across this one? This 15 ohm resistor. What
B,
will
sir.
Yes, beta?
3 volt.
3 volt. How did you get 3 volt, beta? How are these two resistors connected, beta?
Parallel, sir.
Okay, thank God. So if the voltage drop across the 10 ohm is 2 volt, what is the voltage across, drop across the 15 volt? 2 volt only. So the potential drop is same because they are in parallel. Do we remember this? In parallel, potential drop is same. We remember this.
Yes, sir.
So if the voltage drop across the 10 ohm is 1 by 5, 10 ohm is 2 volt, the potential drop across 15 ohm will also be 2 volt. So what is the current in the green branch? You can find out the current in the green branch now. How much will be the current in the green branch? Potential drop is same, 2 volt. I hope you understand this.
2 by 15, sir.
Okay, good. See, simple. There are different ways to do this, 2 by 15. Now, if I know the current in these two branches, I can find out the current in the main branch, yes or no? Current in the main branch, can I find it out, yes or no?
Yes, sir.
What is the value of this I? Everything I hope you can see on the screen. What is the value of I?
1 by 3, sir.
How did you get 1 by 3, beta? So you just have to add 2 by 5, 2 by 15 and 1 by 5, yes or no?
Yes, sir.
So you get how much? 1 by 3.
Yes, sir.
You know the total current, then that is the total current in the branch is 1 by 3. This 1 by 3 is equal to total voltage. Both the batteries are connected in the same way. 3 divided by the total resistance R, yes or no?
Yes, sir.
Very good, sir. From here, you can get the value of R as 9 ohms, sir. Yes, sir, or no, sir, sir? This is the total resistance of the circuit. These two are in parallel. These two are in parallel. So what is the effective resistance of these two? What is the effective resistance of these two? 15 and 10 in parallel?
6, sir.
6, sir. 6 and 2 are in series, sir. So how much becomes the
8,
resistance?
sir.
8, sir. Now 8 is the resistance of the outside resistor. So whatever is remaining is the resistance of the two batteries put together. The two batteries put together is 1 ohm, sir. So what is the resistance of each battery, sir? It is 0.5 ohm, sir. That is the answer, sir. And that is how we do it, sir. We get this? Do we get this, beta?
Yes, sir.
So these are the questions that are going to come. I'll give you one more so that you understand what you have to do to solve questions. And remember, all these questions are from the same series. When I say same series, that means the same year, but different sessions. So this is the question. Now this one is a straight one. In the figure shown, what is the current in ampere drawn from the battery? This is a straightforward one. They are simply asking you to find out the current in the current which is flowing through the battery. Can you do this, beta?
Yes, sir.
Okay, I'll give you 2 minutes to do this. Yeah, so we got an answer here.
Yes, sir. A.
A. Okay, I'll take that answer as A. Everyone got A? How are you supposed to do this?
Junction law, sir.
Yes. You just have to apply junction law at all the points and you should be able to get the answers thereafter. Everyone got this? Yes or no?
Yes, sir.
Okay. Let us move ahead and do one last question from the previous year so that we cover all types of questions that have come that we have covered up till now. There are some more questions left which we will do after we are done with this chapter. Here, this one. Now it's a very simple question and I'm expecting a very simple answer quickly enough. The equivalent resistance of the circuit given between the points A and B is how much? It's a very simple question. I'll give you 2 minutes to do it. Remember, all these questions are from your previous years. Well, option 4 I think is the correct answer. You should not have taken so long. Anyways, how do you get this? You can see this wire like this. That means this resistance is shorted. This resistance does not come in the circuit. The only thing you have to understand in this question is how these 2 and 2 are connected. How these 2 and 2 are connected? Are they connected in series or are they connected in parallel?
Parallel, sir.
They are
Parallel.
connected in parallel. So 2 and 2 in parallel become 1. 1 and 2 in series become 3. So effectively you will have 3 resistance of 3 ohms which are connected in parallel. So the answer is 1 ohm. You have taken some extra time for solving this question. Anyways, I will give you that one that you have solved this. Everyone understands the type of question that you are supposed to encounter in the examination hall. Do we understand? The question that you are
Sir.
going to encounter will be of one, what should I say? One circuit only. Series parallel one circuit only. That is what they are going to give you. They will not give you anything more than one circuit. Can I move on?
Yes, sir.
Okay, let us move on and see if you get a question of two branches where you have two batteries connected, not a one battery. How are you going to solve it? We have already seen that we can solve it using the concept of Kirchhoff's law. You can make two loops. Do we remember this? But now we will see one more method of getting to your answer quickly. And that method is known as what I call it and what it is known as the Nodal theorem. This Nodal theorem, I thought that while I was preparing for my JEE, I had invented this because I could not see it anywhere in the books that were there with me. I did not find this, and at that time there was no internet to find anything about it. Anyways, obviously, it was not invented by me. It was invented by someone else, but I used to use it, and I used to get answers pretty quickly using this. And I'm going to share how we do it. Now, in books, you may find it done in a different way. I don't know how books do it, but I'll just tell you my way, which I devised in the year 1996, I guess. So I'll just tell you my way of doing it. Now, first of all, you have to understand what is a node. Now, what is a node? Wherever you have three branches of current meeting, not two. Meeting of two branches may not be a meeting because it could be like this. The wire may be just turning like this. This is not a node. So this B is not a node. Two branches meeting is not a node. If you have three or more than three branches meeting at a point, it becomes a node. So here point A is a node. Now, since this what should I say, method involves this node, therefore I call it, or we call it, nodal theorem. Now, how are you going to use this nodal theorem? Let us take the example of a very primary circuit, and that is the circuit we actually started with. Let me first start with resistances. Whatever I do with resistances, the same thing I can do with capacitances. We have understood this. Now, if I have a very primary circuit like this, EMF E1, EMF E2, resistance R1, resistance R2, and this resistance R3. Now, you can see that this circuit is exactly similar to the circuit that we solved using Kirchhoff's law. I'll just take you back there just to refresh your memories, because I have this notion that you forget things. So this was the diagram from which we understood Kirchhoff law for two loops. Do we remember this diagram?
Yes, sir.
And we had solved it. We had got two equations. We had solved questions based on those two circuits, and we have got answers, and everything was fine. Now, the same circuit, as you can see, we had two equations. So we had to solve for two variables, I1 and I2. Do we remember this?
Yes, sir.
We had to solve for two variables. Okay. What I'm going to do is trying to solve this with one equation. And that is where the Nodal theorem becomes a very powerful tool. Now, as you can see, there were two variables. Now, in no way can you imagine that this equation can be solved by using only one variable. As you can see, there are two unknowns in that equation. One was I1 and I2. I mean, there are two unknowns, therefore you have to make two loops. Now, what we are going to attempt here is to solve the same question, same circuit, but only taking one variable. How is that possible? When there are two unknowns, how can I make two unknowns into one unknown? Okay, so I'm going to do this way. I'm going to identify the nodes of the circuit. As you can see, there are two nodes in this circuit. Let me call them as A and B. Do not write anything now. I will give you time to write it. Then only you write it. Do you understand this? Just now, put all your concentration on the board. This is the time when you watch the board. You don't watch the board when you write. You only watch the board when you understand. Okay. So all eyes on the board and try to understand. So now I've identified two nodes. Do we understand this, everyone? There are
Sir.
only two nodes in this circuit. Now, what I'm going to do is this some theatrics. I will just ground this point B. Now, what I mean by grounding this point B is basically I'm taking the potential of point B as 0. Remember, potential, the absolute value of electrostatic potential is not defined. You can take one point as 0, a reference point, and then you can define the potential of all the points. Do we remember this?
Yes, sir.
That is what I have done. I've taken the potential of point B as 0. The only way of saying it is I've earthed this. Now, if I take the potential of point B as 0, now I can call the potential of point A as VA. This is not actually VA, this is VA minus VB. Do we understand this? Because this potential is calculated with respect to point B. Point B has been taken as the 0 potential. So far, so good. Everyone understands this? Huh?
Yes, sir.
Now what I'm going to do? Now I have three different branches now. I will assume current I1, and that is why I call the resistance as R1. Current I1 going in this branch, current I2 going in this branch, and current I3 going in this branch. All currents I have taken are outgoing. I1 outgoing, I2 outgoing, and I3 outgoing. Obviously, this is not possible. At least one of them has to be incoming. Anyways, doesn't matter. Doesn't matter. Now I can apply the junction theorem at point A. When I apply the junction theorem at point A, I will get I1 plus I2 plus I3 will be 0. Do we understand this? Yes or no?
Yes, sir.
Junction theorem, one has to be incoming. Simple as that. I'm not taking one as incoming and two as outgoing. I just don't want to complicate things. I just want to keep them simple. As I told you, I'm a donkey and I like to do things in similar way, one way. And I do it, I want to do it in the simplest possible way. I'm a lazy person. I don't want much. I1 plus I2 plus I3 is equal to 0. Now what I'm going to do is I'm going to find the value of I1. How I'm going to find the value of I1? Now to find the value of I1, what will I do? I will start from A, move the circuit and end my journey at point B. Need to go from A and end my journey at B. The only thing unknown there is I1, yes or no? So I can find out the value of I1. How do I start my journey? Then remember that Kirchhoff law not applied for the loop. Can anyone tell me what will be the Kirchhoff law in this blue line? Loop law, what? It's not a loop. How can I apply that Ohm's law, Kirchhoff's law here? Can anyone tell me? Remember, the potential of point A is taken as VA and the potential of point B is taken as 0. Can anyone tell me? How
A
will I?
minus I1 R1 minus E1 is equal to V.
So the blue one will become, the blue equation will become VA minus I1 R1 minus E1 is equal to 0. Yes or no?
Yes, sir.
Okay. Now from here I can find the value of I1. Basically the value of I1 will be VA minus E1 divided by R1. Yes or no?
Yes, sir.
Now, at first it looks like, oh, I have to make this equation also. But if you just use some smart work, some smart brain, you have seen the potential of point A is VA and the battery is put in this fashion that the positive terminal is above and negative terminal is below. So I am going from positive to negative terminal. So basically, if I understand how this equation is coming, just use a bit of brain, just use a bit of common sense, use a bit of brain and use a bit of common sense. How did I get the value of I1? Without even writing the equation for I2, I can tell you the value of I2. What will be the value of I2? What will be
A
the value?
minus E2 by R2.
See, it was simple. I don't have to actually write it. I just wrote it once so that you just understand that there is a pattern behind it. So I2 will become, the green one will become, oops, I'm using the wrong colors. I hate wrong colors. Okay, so I2 will become VA minus E2 divided by R2. And I can also write the equation along the third part straight away like this. And without even writing the equation, I can tell you the value of I3. What will be the value of I3?
VA by R3.
It will be simply I3 will be equal to VA by R3. Now what I have done here is, surprisingly, I have calculated everything in terms of VA. And the only unknown here is VA. Now I can put this one here, this one here, this one here, and this one here, and straight away get the value of VA, which is the only unknown in the entire case. I put all these values and I get the value of VA straight away. How do I get the value of VA? VA minus E1 divided by R1, that is your I1. For that, I don't have to write any equation. I just look at the diagram. I say, okay, VA minus this divided by this. Plus the value of I2 is VA minus E2 divided by R2 plus VA, there is no I3 here, there is no E3 here, so VA divided by R3 becomes equal to 0. The same thing that I had done in two equations, now I have done in one equation. The only unknown in this equation is VA. and you can very easily calculate the value of VA. Now, once you get the value of VA, the question might have asked only the potential difference between A and B. The question might be just find the potential difference between A and B. You don't have to go any further. You have solved the question and you stay happy. They might have asked you to find the current in any of the branches. If you want to find the current in the I1 branch, you don't have to calculate I2 and I3. Just find out VA. And from that VA, calculate I1. If they ask you the value of I2, find out the value of VA and then get the value of I2. If they ask you the value of VA, I3, get the value of VA and find out the value of I3. You don't have to get into complicated equation. In fact, even if you don't have to make even this pink equation, you don't even have to make this pink equation. If you understand it, looking at the diagram and seeing how the batteries are connected, listen to me very carefully what I'm saying. Looking at the diagram and seeing how the batteries are connected, I can straight away write the value of VA without even doing anything. Looking at the diagram, taking a deep breath, looking at the diagram, I don't have to do all of this. I don't have to do any of these steps. Whatever I've done, I've done how many steps? One, oops, let me use a different color. I've done how many steps? I've done step number 1, I've done step number 2, I've done step number 3, I've done step number 4, I've done step number 5, I've done step number 6. I don't have to do the 6 steps also. Looking at the diagram, I can straight away tell you the value of VA. What will be the value of VA? E1 divided by R1 plus E2 divided by R2 divided by 1 by R1 plus 1 by R2 plus 1 by R3. I get the value of E straight away just using some common sense. Oops. Common sense is called common sense, but it is very uncommon. So the same question that was done with 2 equations, I can straight away write the answer. Once I know the value of VA, rest should be same. Rest should be simple. Do we understand this or this is gone above our head saying bye bye sir? हो गया sir. बहुत हो गया.
Understood, sir.
बहुत ज़्यादा हो गया. See? Straight away. No questions asked, no answers given.
Understood, sir.
Great. Now I'll give you time. 2 minutes, 3 minutes, 4 minutes, 5 minutes. Do it on your own. Draw this fictitious diagram. Take a deep breath. Do it on your own. And if you can write this red equation on your own, that means you have understood this. Take your time. Okay. This is the question you have to do. This is the question from your favorite book, S.C. Verma. Question number 36. Part A. Find the potential difference VA minus VB in the circuit shown in the figure. So now you have 2 minutes, 3 minutes, 4 minutes to solve this question and get the answer. That is correct. The answer is very simply VA minus VB is going to E1 by R1 plus E2 by R2 divided by 1 by R1 plus 1 by R2 plus 1 by R3. Do we understand this, everyone? How this is done? And to get to this answer using Kirchhoff's law would be almost impossible because you will be caught in so many of, you will be caught with so many of unknowns because the values of E1, R1, E2, R2 are not given. So it will take a tremendous amount of time and energy to get to this answer from that. Everyone understands this, yes or no?
Yes, sir.
So this has gone above that saying bye bye. Bye bye.
Understood, sir.
I'm not getting voices from the other side. Do we understand
Sure,
this?
sir. Yes, sir.
Chalo, thank God, sir. Part B of the question coming now, sir. Again, you have to find the value of VA minus VB. You have 2 minutes to get to the answer. Yes, what are you saying, bacha?
It's same as previous problem, sir. We are getting.
Same as the previous problem, that is correct. VA minus VB will be E1 by R1 plus E2 by R2 divided by 1 by R1 plus 1 by R2 plus 1 by R3. I hope everyone has understood this concept of how it is done. Yes or no? No or yes?
Yes, sir.
Okay, that takes me to the next problem. Again, this is a problem from the same book. Question number 37. So if you have that book and it is not giving you milk, you can use that book and solve this. This is question number 37 from the same book, which gives us milk. I give you 2 minutes, not to take out milk from that book, but to solve the answer and give me the value of potential difference between A and B and current through each branch. They're asking you the current as well. So how are you supposed to do this? There is no current that is going to flow in the outer branch. I mean this one or this one. So we don't have to worry about these branches. Basically your point A comes here and your point B comes here. You can easily find out the value of VA minus VB. Let me call it as V. So the value of V will be E1 by R1. So I can write 2 by 1 plus 1 by 1. Oh, sorry, mistaken. So E1 is 3, 3 by 1 plus 2 by 1 plus 1 by 1 divided by 1 by 1 plus 1 by 1 plus 1 by 1. Straight away you get the answer as 6 volts. Yes or no? To get the value of I1, 6 minus E1, E1 is 3 divided by
6 by 3, sir. 6 by 3.
sorry, 6 by 3. I'm
2,
good
sir.
at calculations. 2. So, I'll just change it. So, I1 will become 2 minus 3 divided by
Minus
1.
1. Minus 1, sir.
Minus 1. So, it is not going like this. This is what I've assumed. It is not going like this. It is coming in the opposite direction. I2 will come as 0 and I3 will come as plus 1. So it is going like this, but the upar wala current is wrong. So I have to reverse the direction of it. Do we understand this?
Yes, sir.
It has gone above our head saying bye bye, sir. Bye bye, sir. Enough, sir. We are done with this, sir. Huh? You understand this?
Yes, sir.
Okay. Everyone got this answer. Now you can do this question. This is from your JEE Mains of 2021 or maybe 22. Anyways, doesn't make any difference to the eventual thing. If you understand the concept, you should be able to do this. And it is quite simple from where I see. This is the question. The value of current in the 6 ohm resistor is, you have to find out the value of current in the 6 ohm resistors, and I'll give you 2 minutes to give me the answer for this one. So what is the answer for this one? What is the value of current in the 6 ohm resistor? Which
10,
one?
sir. 10.
10. Okay, how do you get this? You can just put this as point B, you can just put it at point A, and you can find out V. V will be 140 divided by 20
Plus 90 by 5.
plus 90 by 5 divided by 1 by 20,
Plus 1 by 6 plus 1 by 5.
1 by 6 plus 1 by 5. How much does it come? How much? 60.
Yes, sir.
60 it comes. Okay, then 60 divided by 6, the answer would be 10 amps fair and square. Everyone got this? Yes or no?
Yes, sir.
Do we understand how this is done?
Yes, sir.
If you get a question where you have two branches, I mean, it becomes more simpler than the previous one probably. But then you have to understand how you have applied this, and I hope that you will remember this. Yes or no? No, yes.
Yes, sir.
Sir.
Okay, I was looking at a question. Let me get to that question. Not this one, probably. Should get. First, let me do this one. Again, this is a question from your JEE Main. Just give me a couple of seconds. This thing it sometimes gets heated up and it gives all sorts of trouble. Anyways, it is still there. So you can see and get the answer for the circuit shown in the figure. Some values are given and they are asking you the whatever the is. Get me the answer and stay happy. So let us not talk about the answer. I will just tell you, let us just do it in that way. Let us first find, let me call this point as ground and let me call the potential as V. Let me just find out the value of V. What is the value of V? 2 by 1, E1 by R1 plus E2 is 4, 4 divided by 2 plus, okay. Now you have two resistances in the third branch. Don't worry, you can replace these two resistances by one resistance because the current is going to be same in all the in the two resistances. So E3 will be 4 divided by R1 plus R1 will be 2. Do we understand this? Divided by, okay, in the first branch also there were two resistances. I did not see that. So it will be 2 by 2 and it will be 1 by 2 plus 1 by 2 plus 1 by 2. Whatever is the answer is your answer. Do we understand this? Do we understand how I have done
Yes, sir.
this?
Yes, sir. Sir.
Whatever you get from here is your answer. Shall we move ahead in life?
Yes, sir. Yes, sir.
Okay, one more. Do it fast. The faster you do, the more confidence you will get. It's all about confidence. You have taken a lot of time in the previous question, which was unexpected. I hope you can do this one faster, quicker. I'll give you 2 minutes to do this. Okay, so how are you supposed to do this? You have to find the potential difference between the points A and B. As you can see, between A and D, it's an open branch. Nothing can happen here. So there will be no current. So this point is actually not D. This point is actually A. Forget about this. This point, nothing is going to happen. So this point is B.
Option D, sir.
You've taken too much of time, my dear friend. Taken 5 minutes to solve this one. You have to divide 1 by 1 is 1, 2 by 1 is 2, 3 by 1 is 3, 1 plus 2 plus 3 is 6, 6 divided by 3 is 2. I have done it orally in 5 seconds. And I'm a 43-year-old man.
But we are thinking about external,
5
sir.
seconds.
We are thinking about external.
You to keep on thinking about things that are not in the universe. You're worried about the 96% of the universe and you're not worried about the 4%. Same question we did from your favorite book, and I told you there also. This is a replica of the same question, beta. Same question from S. Verma had come. Same question, same question, same question. Open your eyes. Take a deep breath. The same question. Shameful. Shameful act. Utterly shameful act. Utterly, 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 to the power infinity, shameful act. Anyways, students are like cash vouchers. Sometimes the cash voucher may not work, but I'll give you one more chance to redeem yourself. And this is your redemption, Shawshank redemption. How much current is flowing from where? You have 2 minutes to redeem yourself. Everyone got option B, or someone is getting different answer? How are we supposed to do this? Let me call this point as 0. Let me call this point as V. So I can just write the equation simply. This V will be equal to 6 divided by 3 plus 9 divided by, I think it is 3 plus 2, 5 divided by 1 by 3 plus 1 by 1 plus 1 by 5. Yes or no? Anyone got this?
Yes, sir.
What is the answer you are getting from this? V?
Yes, sir.
Huh? Everyone did it this way now? Yes or no?
3 by 23, sir.
50 by
3 by 23.
3 by 23. V is coming as 3 by 23. Well done. And what is the value of current coming? 3 by 23. So 3 by 23 is 0.13. Is that so? Maybe, yes. Okay. Everyone got this? Yes or no? Please raise your hands. Let me get this. Everyone got this? Well done. Democracy wins on in elections. This is physics, my dear friends. Democracy does not win. And this is an absolutely wrong answer. Why is it an absolutely wrong answer? Because, my dear friends, we have forgotten how the batteries are connected, and you must remember how batteries are connected. This battery, my dear friend, is connected. Oops. Wrong color. This battery, my dear friend, is connected like this. But this battery, my dear friend, the negative terminal is ahead and the positive terminal is behind. No one looked at it. Hey, they there. And therefore, your answer changes. Do we understand this?
Understood, sir.
Too late to understand. So the 9-volt battery will be taken as positive and the 6-volt battery will be taken as negative. So now the question looks like this. This V will be equal to 9 by 5 minus 6 by 3 divided by, the resistance does not get subtracted, remember. 1 by 3 plus 1 by 1 plus 1 by 5. Did anyone do it this way? Anyone was democratically winning. So from here, oh, I see one hand coming from somewhere. So you remember, beta, just because every question is coming in the similar way, that doesn't mean that every question will be like this. It all depends on how batteries are connected. And I can only hope. Hope is the only thing that you can do when you cannot do anything else. Hope. Hope that I'll hope that you will remember this. So from there you will get the value of current. And doesn't matter. I think you should be able to solve it. If you can't solve it, well, in that case, I can't help you at all. Anyone got this answer? Yes or no? Understood what was the problem? What was the different thing? That is why I kept on doing all
Option
the
D,
same
sir.
thing. Option?
D.
Option D. The option has changed to option D. Okay, doesn't matter. I don't know the answer. Must be correct. You should be able to calculate it from here. Because after that, I can't help you anyways. Anyways, now comes this question. Again, JEE Main 2019. One question comes from one topic in one session. Same question, no. Similar question will come from same topic in the next session. I'll keep on saying this.
Sir,
Yes,
so can you please tell the answer for the previous question?
I don't know the answer, but I don't have to go a lot of back. You can calculate it. Calculate it. You will get whatever you get. That is the answer. If the options are not there, the options are wrong. Okay.
We're getting B, sir.
Okay, whatever it is. I have to go a lot of way down beta to check the answer, and I'll forget everything. So let us not concentrate on the answer. You can get the answer and you can do it. Let's concentrate on the next question that is there. Okay. You should be able to calculate it beta. If you can't calculate it, I don't know what I will do. Better I leave it like this. Okay. We move on to the next question, and this is the one. In the given circuit, the cells have zero internal resistance. What is the current in ampere passing through R1 and R2? R1 and R2. You have 2 minutes to show me your talents, else I'll show mine. And if a teacher has to show his talents, that is not a good sign. Okay. So how are we going to do this? Now, if I have to do this, and I will try to apply Nodal theorem, let me call this point as A now, and let me call this point as B. Doesn't matter which point I call A and B. This would be grounded. Potential of this point becomes A. Now, if I try to write the nodal equation for this, you can see that in this branch, there is no resistance. Yes or no?
Yes, sir.
So I cannot write V divided by 0 because then that does not make any sense. So what will happen if you have such a branch where there is no resistance coming? How will you solve this question where you have no resistance coming in this branch?
V is equal to IR, sir.
Yes, I mean, this becomes in fact more simpler than this. Since there is no resistance here, this diagram is actually similar to the diagram where you are given that the potential drop between these 2 points, or let me write the potential drop between A and B is actually given to you beforehand, and that potential drop is 10 volt. So VA minus VB or VA is already given to you. So you know the value of V is given to you straight away without anything. Now, once you know the value of V, you can easily calculate the current in this branch. V divided by R, 0.5. Only option with 0.5 is option A, and that is your answer. You could also find out the current in the other branch. How do I do? So I write the equation.
Minus 10 by 20.
Take a deep breath. and then C. Potential of point A is 10. Potential of point A is 10. And when I go and I write the equation, it will be 10 minus 10. 10 minus 10 becomes 0. And therefore, the current in the second branch is 0. And your answer is simply 0.5 and 0. Do we understand this? Yes or no?
Sir.
So when there is no battery given between 2 points, the question becomes more simpler to apply the nodal theorem. Do we understand this? And you might get such tricky circuits, because I see one more here. From your previous year papers, I see one more here. And that will be the last question for today. And I hope you can do this. If you can do this, that means everything that we have done today, you have understood this. So this is the question. And I hope that you can give me the answer for this one in the below circuit. The current in each resistance is how much? So I think the current is going to be same in each resistance. Therefore, they're asking you what is the current in the each resistance. Do we understand this question? Yes or no? No or yes?
Sir.
What is the current in each resistance? I was hoping to get a quick answer. That didn't happen. Right? No answers till now? Not a good sign. And the answer is 0. Absolutely 0. You take nodal from anywhere. If I call this point as A, if I call this point as B, and if you go in this path, you will find out VA minus VB will be coming as 0. Yes or no? There is no
Sir.
potential drop, so there is no current in this branch. Then if you call this point as C and D, and if you go from C to D in this path, remember there is no current, so you can go straight away like this. Again, there will be no potential difference between this branch and between C and D, and therefore the current in this branch is also 0. Do we understand this?
Sir.
And similarly, if I go from this point to this point, E and F, I will end up with the same result. All the batteries are cancelling out each other. We call it cancelling batteries. One battery is put in like this, the other battery is put like this. So they cancel each other out. They are of equal voltages. They cancel each other out. And the answer is 0. Do we understand this, or this has gone above our head saying bye-bye?
Understood, sir.
Understood, sir.
Understood, sir. Your understanding is difficult to understand because you understand that, sir, but you get trapped in very simple questions. See, I've told you everything that you need to know. And any question that comes, I can give you in writing that you can do it from here. But in the examination hall, you have to apply your patience and common sense and have this faith that you can do this question. One thing though remains. We have seen the nodal theorem for resistances, and we have applied in so many questions because question on resistance come more than the question on capacitance. But one thing remains, and that is the nodal theorem for capacitance. And we will continue. We will do that nodal theorem for capacitance in the next class. And since there are not many questions, we will do 2 or 3 questions. If you understand the concept, questions are same, because every question which had a resistance, I can just remove that resistance, put a capacitance, and the question becomes a question of capacitance. Instead of asking you currents, I will ask you charges, and that's it. Do we understand this, or this is gonna power it saying bye bye?
Understood, sir.
We have done each and every question that was possible in this universe that I could find out anywhere up till the topic that we have covered, and I've covered everything that was possible. There's no question that can come out of this. I can assure you that. But again, how you do it in the exam is all there, because I can only teach you. I can't go and give you exam and pray that I don't have to give you exam, because then you will not be doing well, because I cannot calculate simple things. Okay, on that note, I will sign off this class, and we'll meet in the next class. And now we are left with a very small portion of this capacitance. We have covered a major part of resistance as well. So basically your two chapters are going hand to hand, and probably what I believe and what I plan is, like, by 25th of December, by Christmas, the Merry Christmas, we must be able to finish your this part, so that I can start from 26th or 27th. I can start with your magnetic field wala part and wind it up in due time. So that would be my plan. I hope to see you. Do solve the question from SC Verma. Whatever topics we have done, we have not done emitter, voltmeter, so you might not be able to do those questions. Forget about them. You will be able to do it once we have done that part as well. Okay, chalo then. I will take leave. I hope to see you tomorrow. Take care. God bless you all. Bye bye.
Bye, sir.